All right. So what you're looking for here is pairs, not necessarily square numbers. You're looking for pairs. If you learned this from Coach Mack, he does square numbers. That's just how he's always done it. It works. It's the same skill. The reason I do it this way is because when we get to cubic roots, you got to look for sets of 3. And it keeps you from having to memorize all of the square numbers ever. And it keeps you from having to memorize all the cubic numbers ever. Because nobody can do that. I can't do that. I don't look at a number and say, oh, I know that the square number 49 goes into that number. I don't know that. But the small numbers I can tell go into it. So like if I look at 32, I don't think 16 when I see 32. Even though it makes sense now that I say it, but I don't think 16. I think 8 times 4, which is regular multiplication tables. You probably only learned them to the 12s if you learned them that far. 12s is where we had to go to when I was in 6th grade. So that's where I learned them to. Earlier grades than that. Ours were, Miss B gave us timed quizzes when we were in 6th grade. Did you? Good. Good. You should know them by now then. All right. So 140, 14 and 10 is a good way to multiply to be that. Neither of those are square numbers. And that's okay. 14 breaks down to 7 and 2. 10 breaks down into 2 and 5, right? There's a pair of 2s. So what comes on the outside of the square root? 2, because it's got a pair. And then 7 and 5 go back in the side, and that makes radical 35. It's starting to make a little more sense there. You remember? All right, good. That means I did something right back then. Yeah, hopefully this makes it click. I mean, this is, and depending on who's teaching it, which way you learn it. I like the factor tree method because it works no matter what route you're taking. Yeah, you're a couple years older now, so it makes a difference. Let's do 72. That's a good number. I like that one. 12 and 6. We could do 8 and 9. Either of those. 12 and 6 would be 2 times 6, and then 3 times 2. There's a 3 times 2. So here we have a pair of 2s. It doesn't matter which 2 2s you use. And a pair of 3s. So what's going to be on the outside? Yeah, 3 times 2. Go ahead, Jordan.
Why wouldn't we do 2 and 6 and 3 and 2, like the 2s, and then 6 times 3?
What you would, the pitfall of doing it that way, it works on this problem. The pitfall of not stopping here and saying a pair of 6s is that they're not prime numbers. There might be, you want to do your factor tree until you get the prime numbers is what you want to do. This one happens to work out where that's okay to do that. Sometimes there might be more pairs involved if you go ahead and break that number down. So that's 6 radical 2. Easy enough, right?
Why didn't we do 2 times 2?
Because the pair, this 2 and this 2, is a pair. It represents one set of 2s, yeah, when it comes out. Because when you're coming out of the square root, you're coming out as a pair. Okay. All right. Now, let's look at operations a little bit with these, with just square roots. And multiplying is something we do, a fair amount of times in here. So let's talk about how to multiply. It's really easy. Let's say you had square root of 10 times the square root of 15. And I'll go ahead and tell you, don't simplify the radicals first. Okay? Go ahead and multiply first. And the rules for multiplying square roots or radicals is outside times outside, inside times inside. So if they give you one that's already got a number outside of it, you're going to multiply it by any other number that's outside, like a coefficient in front of an x. You multiply those numbers together. So we're going to multiply these both together because they're both on the inside. So that turns into the square root of 150, and then break that down. Yeah, and I don't even think too hard to break that down. Got a pair of fives. 5 radical 6 is 3 times 2 is 6. Oh, it's not. It's really, well, the multiplying, then we're going to get some fractions involved in that. Everybody panics when you say fractions. My Algebra 1 class been doing fractions all week. We've been doing fractions, so they love it. Okay, now here we have a couple of them that maybe were simplified beforehand, and then they said, okay, multiply those together, and you got a number on the outside and then some numbers on the inside. So the rule is outside times outside, inside times inside. So we're going to 2 times 3 is 6, and then 6 times 14. Yeah, there's a 14 inside there. So 60 plus 84. Yeah. 6 times 10 is 60 plus 24. And then break down that 84. I can use 6 and 14. Or you could use 12 and 7. So 2 and 3.
Since you got 3 and 2 and 3 and 2,
So what about the 6?
how do we pick?
What do you mean?
Like, how do we pick what goes on the outside and what goes on the inside? Since there's 3 2s.
There's not 3 2s.
On the 14.
14 is 2 times 7. Yeah. Be
Be
careful about your.
to do the other side too.
Now, the outside, we multiply those together to get this 6 that's on the outside. And then we just broke down 84. I just used the 2 numbers that we used to get 84 and broke those down. So we got a pair of 2s. So that 2 is going to come out here with the 6. And what's it going to do to the 6?
Make it 12.
Make it 12. It's going to multiply to it. That's right.
So it's 12, 21.
And then 21 left on the inside. So that's 12 radical 21. Yeah, this is the final answer for that.
21.
7 times 3.
These guys that didn't have pairs multiply back together.
Okay, did you just take like that was 6 square root of 84? Did you just take it and multiply by 2?
I multiplied this 6 times this 2
Okay,
that's from the pair. That's where that's coming from. The 6 that was already out there. Okay, so multiplication, the rule is outside times outside, inside times inside, then simplify. Okay, put it in your bag. All right, let's throw the fractions in there. This is where some of us have a little bit of problem because we just don't like fractions. We get nervous about it and it gets us uptight and we can't work them. Not because we're not smart enough. It's because we just get nervous. Okay? All right. With fractions, the best thing to do is split it apart. If we're taking the square root of a fraction, you can split that into the square root of the numerator and then the square root of the denominator. And then it becomes just 2 separate problems that we need to work. And this one works out real nice because what's the square root of 9? 3. And the square root of 64 is 8. And we know that from the factor tree on a 9 is 3 and 3, and the factor tree on a 64.
So is that the answer?
Yeah, 3/8 would be the answer to that. And because they were both square numbers, we could just take those square roots. If you did it by factor tree, this is why it's happening that way. You got 1, 2, 3 pairs of 2s. That 4 is not part of that. I don't know how to represent that really. Highlighter would be the best thing, I guess. 2 times 2 times 2 is 8. That's where that's coming from. So we get 3/8. That works out really nice.
So you did like 2 cubed.
2 to the 3rd power. That's what 8 is. Yeah.
That's what cubed is.
Yes, sir. Yeah, that is correct. All right. Let's go. We're at 11 over 25. So the kind of the next level up. So this is easy level. Let's go to what is it, intermediate or whatever the next level up.
Well, 11 is prime, is it not?
Yeah, it is. So when we split that apart, we get the square root of 11, and then we know the square root of 25 is 5. So you can't break. That's prime. You know it's not going to break down any. So you just leave it like that. It's okay to have a square root in the top. Not at the bottom. We'll get there in just a second, okay? So it's okay to have a square root in the top, but not in the bottom. So that's the final answer for that one.
Why did we put a square root sign on 3?
Because the square root of 9 was 3. Because we had taken the square root to get the 3 and the 8.
Oh, okay.
Just like we don't put a square root on the 5 because we took the square root of 25 to get there. Okay. Let's go right here. This one's just a fairly short one. Let's do 25, or better yet, let's do 24 over 25. That's a good one. So it's a similar, I put it right beside it because I wanted it to be similar. That when you split that apart, we still get the 5 on the bottom because the square root of 25 is still 5. It hasn't changed. But what about that 24?
It goes 64 and 3.
Yeah. Break it down. Get a pair of 2's. So 2 radical 6 over 5.
Did you get the 6 from 3 times 10?
Yes. Yeah, the 3 and the 2 that were left over on my factor tree, that's where that's going. All right. So square root on the top is okay. Square root in the bottom is not. The reason it's not, and you may remember this from my classes, you can't take this piece of paper here and cut it into square root of 2 pieces. Not by hand. So, like, I can take this piece of paper. If I told you the area of this piece of paper was 2 radical 6, and I said split it up into 5 equal pieces, you could take a ruler, measure it out, and cut it into 5 equal pieces. That's easy to do. You can't do that if a square root is in the denominator. And let's look at that. This is, I don't know what letter we're on. K. You mean J? No, we did J. We did K. Thank you. Sorry. I glanced at the one on the left.
That last part about the denominator on the bottom.
Mhm.
That went out of my head.
Yeah,
All right. So let's look at an example. I think you're going to see what I'm talking about. All right. So here we have something that is square root of 3 size, and I say, okay, now cut that into square root of 2 pieces. What does that mean? Doesn't mean anything, right? We can't visualize that. If I said this piece of paper is the square root of 3, and you cut it into 2 pieces, does that make sense? Because I can cut it into 2 pieces, but by really perfectly by cutting it in half right along that crease, right? That's what's called a rational denominator. What's a rational number? Go ahead. Well, not necessarily even, but if something is rational,
It goes out equally, right?
yeah, but it may not go out equal either.
What is it?
What's the first 5 letters? Ratio. How do we normally write ratios in math class? Well, or as a fraction. Rational numbers are numbers that can be written as fractions. Okay, so like 2 is a rational number. I can cut something into 2 equal pieces. Okay, 1/3 is a rational number, even though it's not a terminating decimal, doesn't go evenly. It's still a rational number. Square root of 2 is not rational, meaning that if you type in square root of 2 on your calculator, you get this decimal that never repeats and never ends. It keeps going forever. Your calculator will only give you like 10 digits of it, but it doesn't repeat and it never ends.
So it's like pi?
It's kind of like pi, yeah. Kind of like pi. Now, what we want to do is rationalize the denominator, is what this is called. Rationalize the denominator. And to rationalize the denominator, you multiply by the square root part of the denominator. Well, the square root in the denominator is the square root of 2. So this is why we had to talk about multiplying before we started doing other stuff, okay? Because here I'm going to multiply square root of 3 times the square root of 2, which turns into the square root of 6. And then on the bottom, the square root of 2 times the square root of 2 is the square root of 4. But we know the square root of 4 is 2. Square root of 6 over 2. And it goes right back, but it doesn't have the square root on it anymore.
How do you know what to,
I thought it was gonna go back
how'd
to
you know?
3.
to
That's why I was
multiply
like,
by
it's gonna
two?
go right back.
You
Because
multiply-
the square root that's in the denominator, what I'm trying to do is get rid of the square root, so I'm trying to get that squared in there. When we get the cubes later on in the book, we'll need 3 of them, so we would have to multiply by like 2 squared. We'll get there. There's a lot of skills in between now and then that we got to get. Let's look at another one. Let's say we had square root of 25 over 18, like a fraction like that, all of that under the square root. So we got to kind of combine this with what we just talked about simplifying a square root of a fraction. All right, so, square root of 18 is not 9. Square root of 25 is 5. The square root of 18 doesn't work out real nice. So let's break down that. 9 and 2, 3 and 3. So a pair of 3s. And then the 2 stays on the inside. All right. Now, what part of that is the problem in the denominator? The square root of 2. That 3 in the denominator is not the problem. The square root of 2 is. So that's the part we've got to rationalize with. So we rationalize by multiplying by that square root that's in the denominator. Because if I multiply square root of 2 times another square root of 2, it gets me square root of 4. And that cancels out the square root because we know the square root of 4.
So if you times it by 3 and get 12?
No. Well, you won't get 12, you'll get 6 because the square root of 4 would be 2.
Oh.
All right, now, what are we really multiplying by here? What's square root of 2 divided by square root of 2? 1. So it's not changing the value, it's just changing how it looks. Okay? It's like this piece of paper is still a piece of paper. Whether I fold it in half, if I wad it up, it's still the same piece of paper, just looks different. Okay? So what we're doing is just changing how the problem looks, making it a rational denominator. And then we get 5 radical 2 on top, 3 radical 4 on the bottom, which y'all said was 2, which is right. So that's 3 times 2. And I'm just trying to show every step along the way. I would expect you probably to just go ahead and get to this.
Do we leave it 5 radical 2 on the top?
That should be a 5 on top. Sorry, I got in a hurry and wrote the 6. 5 radical 2 on the top is absolutely fine. Now we have a 6 on the bottom. How? You saw it?
I didn't. How'd you get the 6? Oh, okay.
That right there. 3 times 2. The square root of 4 is 2.
Right.
Now that. Okay. Let's do another. All right. Let's do this one. Square root of 17 over 72. Picking some numbers.
Let's call it a day after this.
We still got a few more. Just a few. 1, 2, 3 more. After this one. So we're going to split it apart. And then what you want to do when you split it apart is go ahead and simplify the denominator especially. You can kind of get by with not simplifying the numerator if you just want to wait, because you're going to have to multiply anyway at some point if there's something left in the denominator. So I always kind of just start with the denominator and go from there. So 72, 8 times 9, that's 4 and 2, 2 and 2, 3 and 3. So what's it simplify to be? 6 radical. There's an extra 2. Here's a pair of 2s. Here's a pair of 3s. Got a pair of 3s.
Oh, I did it wrong. I
Got a pair of 3s and a pair of 2s. So that's 3 times 2. That's this 6 that came out. And then this 2 left over is where it comes on the inside there. You got to make sure you get your factor tree right so you got the right numbers there to pick from. It's very easy to make that mistake. Okay, Kylie?
Okay. Shouldn't there be 3?
There's a pair of 2s. Yeah, so 3 times 2 is where I'm getting the 6. Yes, there's a 3 that comes out. Yes, there is a 2 that comes out, but they multiply together. Now, what's the problem piece of that denominator? Radical 2. He seems to be an issue a lot. So that's going to give me square root of 34 on top, 6 radical 4 on the bottom. Times 2. So I end up with final answer of square root of 34 over 12. Keep in mind, though, that we would need to try to break down the 34. But I know it came from 17 times 2, and 17's prime. So it doesn't break down any. So if that number were to break down, you know, hypothetically, if you had a square root of 24 on top, and then a 6 or 6 times 2 on the bottom, and 12 on the bottom, then you would need to simplify the 24 and then cross, like, heck, we'll just do that. Now we have 4 examples left, counting this one. It'll be okay. The other ones are not that bad. Let's say you got square root of 24 over 50. You break that apart. I'm thinking, okay, 5 times 10. Pair of 5s. So radical 2 again. And then I'm not simplifying the top part yet. I'll go ahead and rationalize before I do that. The reason being that if I rationalize now, or if I simplify the top now, after I rationalize, I may have to do it again. So I'm just saving myself some work from doing it do the numerator at the end. Okay, so how do I rationalize that denominator? Radical 2 over radical 2. Realize it's not always going to be radical 2, guys. It will change numbers. But it's whatever the square root of the denominator is. That's what you're going to use. Okay? So that's going to be square root of 48 over 10. Yeah, 5 times 2. So I'm just kind of taking that step forward. The bottom one?
Yeah.
Square root of 2 times square root of 2. You know, this comes from 5 radical 4. What's the square root of 4? 2. 2 times 5 is. That's where that's coming from. We're just kind of skipping maybe that step that I've been writing it down there. Now we need to simplify the 48. So I'm just going to break down 48 with the factor tree, 12 and 4, 6 and 2, 2 and 3, 2 and 2. So I got a pair of 2s, another pair of 2s. So that's 4 radical 3 over 10. And here I need to look at that and say, oh, well, I need to simplify that. 4 over 10 will simplify, right? 2 will go into both of them. So that's 2 radical 3 over 5. And if you type, here's how you can check, make sure you're right. If you type in your calculator square root and then 24 over 50 inside of it and hit enter, get the decimal for that, and then type this into the calculator, they better be the same number. So we didn't do anything to change the number. We just changed how it looked. Okay. This 5 right here, 4 and 10. 4 goes divisible by 2. And then 10 is also divisible by 2. So that's where this 2 is the 4 divided by 2, and this 5 is the 10 divided by 2. From my factor tree, I got a pair of 2s and another pair of 2s, so 2 times 2 is the 4. And then that 3 right there is left over. So that's good questions. All right, let's get a conjugate pair problem or two out of this, and we'll go from there. We still got 6 minutes. All right. That's a 7 plus radical 2 on the bottom. These are they look a little bit more complicated, and they are. I mean, they got more stuff in them, so they got to be. And we still see that there's a radical in the denominator, and that's the problem. We can't have that, because I don't even know what breaking something that's a size 3 into a 7 plus radical 2 even means. So I'm going to try to get a plain number on the denominator. The way you're going to have to do that is use what's called a conjugate. The conjugate, so CONJUGATE. It's the same word that you use to conjugate verbs in Spanish class. It's the same word. Conjugate. Conjugate pairs means opposite or the other factor from a difference of squares. The other factor would be this. You change the sign in the middle. That's all you have to do. You don't have to really understand much about a conjugate other than it's just change the sign in the middle and it works. Okay. What it will do is it will get rid of the radical in the denominator. It just by the magic of multiplication. So that'd be 21 minus 3 radical 2. So that's like distributive property on top. On the bottom, it's going to be like FOIL method. You'll say 7 times 7, 49, plus 7 radical 2, and then a minus 7 radical 2, and then a minus, and they will cancel each other out. Yeah, minus the square root of 4. So 7 times 7 is 49. Then we have a positive 7 radical 2 and a negative 7 radical 2. And then the last terms would be negative square root of 4. These radicals cancel out here in the middle. That should happen every single time. If you're using the conjugate, that happens. They cancel each other out. What do we know the square root of 4 is? 2. So we just have 49 minus 2 in the bottom, which is 47. The top is 21 minus 3 radical 2. And we've simplified that. You look to simplify it if you can, but you don't. I mean, there's nothing that works there because 47 is prime. Okay, so that's a conjugate. Conjugate just changes the sign in the middle, and then you multiply top and bottom by that. That's going to be your work there. Okay. Do one more. And we're done. Y'all still got 3 minutes, and it won't take 3 minutes to do this problem. 4 over 5 minus radical 3. What's the conjugate that goes with that? 5 plus radical 3. Good job. Distributive property on top, 20 plus 4 radical 3. The bottom part, shortcut would be 5 times 5 is 25 minus square root of 3 times square root of 3. Square root of 9 is 3. Okay. That's what's going to happen every time. So 20.
Why don't this board, can we not just simplify that? We might just do 5 plus radical 3.
Not.
We did that?
No, that's not 5 plus radical 3. That's 22.
No, I was talking about the top. The 20 plus 4 radical 3.
That you can simplify here with the 20, the 4, and the 22 because they're all divisible by 2. You can't put these two together because one has a radical 3 and the other one doesn't. Okay. So simplify that. Be 10 plus 2 radical 3 over 11. If you want to look at some of these problems tonight, that would be good. We're going to do a little bit of get a little bit of time tomorrow to work on this, but we're going to also get into the solving some tomorrow. Just 3 through 18. So on page 269. It's like the small page there. Some of them are real. Look, I would look at some of it at least tonight so that you're not.
Any junior who would like to be considered for the 2016-17 prom committee needs to pick up a packet in Miss Erin's room, that's room 130. The last thing is submit a packet in